It's good to be here. Thanks so much for having us. My name is Jeffrey Martin. I am co-founder, CEO of Mosaic. We are a geospatial imaging company. My own background is in 360-degree photography, which I've been doing for over 20 years now. I, in a previous life, I made a lot of gigapixel imagery, including a world record. I was in the Guinness Book of World Records, 320 gigapixel image of London. This is a similar image from Tokyo, taken from the top of the Tokyo Tower. This is a few hundred gigapixels. I think it's 200 gigapixels. So this is made from a few thousand images, all stitched together, and it gives you quite a extraordinary level of detail. So I've, for most of my adult life, been quite obsessed with capturing as much detail as possible from every direction. At Mosaic, that is also what we're doing. We make geospatial camera systems along with LiDAR and other sensors, which allow our customers to capture the world in a structured way, in the maximum possible quality, in the easiest way possible. So we take great pride in building systems that are very robust, reliable, and easy to use. You can see our products here. We have a couple of cameras which are made to be mounted on top of a car. We have a backpack device that is for anything else, for walking, bicycles, scooters, what have you. We have an integrated INS and LiDAR product called the Meridian, which allows you to capture point cloud, colored point cloud, and images all together. So our devices can capture things in a lot of different ways. You can do a lot of different stuff with the data. You can create 360-degree panoramas. You can create meshes, textured meshes, point clouds, colored point clouds, 3D Gaussian splats, all of which are pictured here. The one in the center is a 3D Gaussian splat, and that's something that I find to be the most interesting these days. And we'll get into that a little bit later. This is a 360-degree imagery from our Explore backpack device. This is on a railway bridge in Prague. So in contrast to other kind of backpack devices, we are kind of cameras first, LiDAR second. The LiDAR is kind of a supporting actor, but the cameras are the main attraction. This again is from the Viking camera. This is a 360-degree panorama, and then this is from a similar device. This is the point cloud. So we've got a lot of different modalities. Oops. Sorry, I'm going back. This is, okay. So this is a 3D Gaussian splat from our backpack, and I find this technology to be the most exciting because this is a real 3D photograph. It has all the qualities of a photograph, and it captures the environment in the best possible way. If you look at the trees, look at all the branches, look at all these thin objects. You could not do this with a mesh model. You just can't do it. It's impossible. But with 3D Gaussian splats, you can. So this 3D environment, it wasn't possible to do this a couple of years ago, and now it is, and it's tremendously exciting. In addition, with the 3D Gaussian splats, you can capture things that are shiny, things that are translucent and transparent, and it renders it in a realistic way. In the previous technology with mesh modeling, you had to assign, attributes and certain types of surfaces. Is it metallic? Is it shiny? It was a pain. You have to do it by hand. This just does it by itself. But the foundations of it are the same as photogrammetry. You need to capture a lot of images, and you have to register them together you have to figure out, where they are in space, and then from that you can render this 3D Gaussian splat. Here's another one of a graveyard. This is in Prague again. This is where all the most famous Czech writers and artists are buried. Again, you can see the kind of the quality of the environment feels more real. It feels more photographic, and that's what we really like. This data set was captured in just a few minutes. So, in contrast with other types of tools or instruments where you might have a terrestrial laser scanner or a camera on a tripod, it might take a few hours to capture the data. We just walked around here for a few minutes, capturing tons of images, capturing the LiDAR point cloud, and then we were able to render this result in a very short time. Here's another one. This is a cathedral that is right next door to that graveyard previously, and again, you can see stuff that is shiny and stuff that is thin. If you see the strings that are holding the lights, again, this is something that would be impossible to capture correctly any other way. So this is a real kind of foundational change in the way 3D data can be viewed and experienced that was not possible before. So from our devices, some of our customers don't want 3D Gaussian splats, but they want a point cloud, or they want something that they can measure from. So we can offer these types of data that allow you to make measurements, or you might still want a mesh model that allows you to do physics. We've got some customers that are in the visual effects industry for film. They might use this type of data set and bring it into software such as Houdini, where they can do physics to the buildings. They might want to, have a dinosaur destroy the building or blow it up, and like in that software, you can take this 3D data as a physical object and do physics to it. But again, with our hardware, you can do any of these things with the source data and make these different types of data sets. In the development and testing of our hardware, of course, we have to drive around and capture lots of data, and we came to the idea a couple of years ago that instead of just driving around our neighborhood over and over, it might be more interesting to map the whole city and to make an interesting data set. And we wanted to take it a step further, so we've released something called Prague Real Map, which is a data set of over 1 million images captured from a car using our Mosaic X camera. This data set is free for anybody to download and use. It's licensed under a Creative Commons share-alike license. So this means anyone who wants to take these 1.3 million images and do any kind of experimentation, build any kind of 3D model, or AI inference, or I don't know what, anything you want to do, you can sign up, you can download this data, and you can use it for free, non-commercially. We've had a lot of interest around this. We've had a lot of interesting people sign up to use it, from neuroscientists to computer vision scientists, and there's been a lot of interesting feedback from this. We are planning on a new data set, which we have been working on with our backpack camera. We have been walking the streets of Prague for many weeks now. We've captured about 18 terabytes of imagery so far, so it is many millions of images, and we will be releasing something very interesting early next year. So stay tuned for that. That's all I've got for you today. I'm glad you were all able to come and see what we've been up to. Thanks very much for having me.